Hi everybody, I'm Professor Rad, and in this video we're going to discuss z-scores. Now, so far in our numerical studies or summaries of data, we've looked at measures of center, which tells us kind of like what's typical in a data set. We've explored measures of dispersion, which tells us how spread out the data set is. We've looked at percentiles or quartiles. So a reminder, if you're in the 75th percentile, that means that you outperformed 75% of the other people who took the test. But none of these measures so far tell us how we perform with regards to the mean. And that's what we're going to look at today. So a z-score is going to tell you how many standard deviations above or below the mean a value is in a data set. So just as a reminder, the standard deviation is like a typical difference from the mean. So if I'm one standard deviation above the mean, that means I scored like above average, like the average distance above average. Okay, in other words, I'm pretty close to the mean. If I have a z-score that's a -3, that would mean I am 3 standard deviations below the mean. In other words, I am 3 times as far from the average as the average distance from the average, and I'm below average. So if this is like a math test, having a z-score of -3 is not great. But if this is like risk for a particular disease, having a z-score of -3 is wonderful. It means you have a lot less risk than others. So let's see how we can use z-scores to help us compare values that are on, values that are on different scales. I suddenly have the hiccups, so I apologize in advance. Okay, so on this example, it says Helen scores a 28 on the ACT and a 680 on the math portion of the SAT. So, okay, presumably in this case, I guess Helen is going to want to know which of these two numbers should she report to, some place where she's applying to. So if I just compare 28 and 680, obviously 680 is bigger, but the SAT and the ACT are on different scales. So I can't say that 680 is better than 28 just because it's bigger. So I have to see, is it bigger relative to the scale that it's being measured on? So here it says the ACT has a mean of 21.2 and a standard deviation of 5. We want to find Helen's z-score to the nearest hundredth on the ACT. All right, so the information they're giving us is for the ACT in general. So that means this is population data. So I'm going to use mu for the mean and sigma for the standard deviation. The mean is 21.2. And the standard deviation is 5.0. And let's see, Helen scored in 28 on this test. So that's her value. That's what she got on the test. All right, now I kind of glossed over the formulas before, but here's what we're going to do. We're going to see, I'm going to use this formula since we've got population data for this problem. So we're going to see how far are we from the mean and then divide by the standard deviation. So we get an amount of standard deviations. So z is going to be my value x, which is 28, minus mu, which is 21.2. And then we're going to divide by the standard deviation. So our standard deviation is 5.0. All right, there we go. So I'm going to throw this into my calculator. So I'm going to put in a parentheses, 28 minus 21.2, close up those parentheses, and divide by 5.0. This calculator is giving me it as a fraction. So I'm going to press this S to D. So I think that's specific to decimal. That's how I think of that. So you want to make sure you know your calculator so that you know if you need to change to decimal format or not. And I get a 1.36. Now, this problem told us to round our answer to the nearest hundredth, but this problem is already given to the nearest hundredth, so we don't have to round. Cool. Now, for part B, it says the math portion of the SAT has a mu of 515 and a sigma of 116. And we want to know, what is Helen's z-score to the nearest hundredth on the SAT? So Helen scored a 680 on the math portion. So we're going to do the same formula. So z is x minus mu. So her x in this case is 680 minus mu, which is 515, over the standard deviation, which is 116. All right, so let's bring our calculator back in, and we'll do 680 minus 515, close up those parentheses, and divide by 116. Change that to decimal. Oh, golly. So we get a long repeating decimal this time, but they want it to the nearest hundredth. So find our decimal point. Immediately to the right is the tenth, followed by the hundredths. So to the right of the 2 is a 2. So since this is 5 or smaller than 5 rather, this is going to stay a 2. So we end up with 1.42. Okay, so here's what this means. This means that Helen scored 1.36 standard deviations above average on the ACT. So she did more than the average distance above the average, or more than the mean distance above the mean on the ACT. And same thing here. She did well on the SAT as well. But this one, she has 1.42, which is a little bit bigger than 1.36. So that means comparatively, she did a little bit better on the SAT than she did on the ACT. So on which test did Helen perform better? She performed better on the SAT. All right, so very often in math, once you learn a forwards direction, you might want to learn a backwards direction as well. So let's talk about how we can go backwards. So I have a note up here. There it is. If you have a z-score for a data value, you can go backwards and figure out the data value by rearranging the formula. So instead of doing x minus mu, we're going to have a plus mu over here. And instead of dividing by sigma, we have a multiplying by sigma. And I'll point out these formulas, same thing with the z-score formulas. I used both the population and sample notation. They're the same formulas, just different symbols. So like sigma and s are standard deviation, mu and x bar are mean. So if it makes it easier for you, you can think of it in terms of words. So z times standard deviation plus mean, or in the case of the z-score formulas, you could think of it as value minus the mean over the standard deviation. Because again, it's the same thing, just different symbols depending on context. All right, so let's go ahead and work through this example about Ted to see how he did. So it says Ted scored 1.44 standard deviations below the mean on the ACT and 0.87 standard deviations above the mean on the math portion of the SAT. Recall that the ACT has a mean of 21.2 and a standard deviation of 5, while for the SAT, mu was 515 and sigma was 116. We want to know, what did Ted score on the ACT and what did Ted score on the SAT? All right, just to make this easier for me to digest this information, I'm going to do the ACT stuff in red ink and I'm going to do the SAT stuff in black ink. Whew. Okay, so we've got our ACT and he scored 1.44 standard deviations below. And then for the SAT, 0.87 standard deviations above. The ACT has a mean of 21.2 and a standard deviation of 5. And for the SAT, mu is 515 and sigma is 116. Okay. So notice in these formulas, this time we're looking for x. So in order to find x, we're going to need z, sigma, and mu. So I'm going to write here z, sigma, and mu. Now mu is the mean, so we get 21.2. Sigma is the standard deviation, so we're going to get 5. And z is the number of standard deviations you score above or below the mean. So this 1.44 standard deviations below the mean is telling us the z-score. It's telling us that the amount is 1.44. And since he scored below the mean, that means he has a negative z-score. So if I want to find what he scored, that means I'm looking for a value. What was his actual score on the ACT? So I'm looking for x. So x is going to be z sigma. Now remember, when there's no symbol in between, it means multiplication. So I'm going to do negative 1.44, because that's z, times sigma, which is 5.0, plus mu, which is 21.2. So we can go ahead and type this into our calculator here. Just trying to find a spot for it. So we can do a negative, where's my negative here? Negative 1.44 times 5.0 plus 21.2. And I get 14. Now, if this was like dollars instead of a score on the ACT, I would want to make sure I label the x value. Notice z-scores do not get a label, but the x values would. But since the ACT doesn't have any label to it, it's just a score, we don't have to put anything there. And then I didn't have to round this one because it came out to be a whole number. All right, so let's repeat this process now for the SAT. So I know I'm going to need a z, a sigma, and a mu. So z is the number of standard deviations above or below the mean. So he has 0.87 standard deviations above the mean. So since it's above this time, that means we're going to get a positive z-score. And then they tell us sigma is 116 and mu is 515. All right, so let's go ahead and use our formula here. So x is going to be z times sigma, which is 116, plus mu, which is 515. So 0.87 times 116 plus 515. All right, and this time we ended up with a decimal. So to round to the nearest whole number, here we've got our decimal point with a 5 in front. Just to the right is a 9, so that means that 5 is going to round up to a 6. So we're going to get 616. Again, if this was in reference to like dollars or something, I would want to make sure I label it. But since the SAT score doesn't have any label, we're just going to leave it like that. Okay, so that's going to wrap it up for this video on z-scores and then going backwards, finding the x values. I hope you found it helpful, and I hope you have an excellent day. Bye for now, everybody.